Hello, my name is Justin Luong, and today I will be introducing a Group 4 project with speakers Shawn and Daniel Sanchez. The topic they will be debating will regard the presence of neutrinos and muons on Earth. Neutrinos are subatomic elementary particles that have no charge. They are created from the formation of stars, black holes, supernovas, and radioactive decay. Muons are the result of a neutrino colliding with the nucleus of an atom. Neutrinos are important to science because they contain information of their origin, which furthers human understanding of molecular science. Our debate topic will be about whether or not neutrinos that come from other galaxies can come in contact with Earth. Shawn, what are your ideas about this topic?
Well, I believe that since neutrinos travel faster than the speed of light, it is very possible for neutrinos to travel to our galaxy from extragalactic events, such as supernovas, black holes, quasars, and other cosmic phenomenons. I think this because a study in Antarctica examined 35,000 neutrinos, and 20 of them had energy levels so high that it is possible for them that they came from another galaxy. Also, neutrinos have been around for billions of years, which is older than our galaxy, meaning that they are not of this galaxy. Additionally, neutrinos are birthed from supernovas, and since our solar system only has one star, they did not originate from our solar system.
Alright, thank you, Shawn. Daniel, what are your opinions about this topic?
Alright, thank you. Well, I think that statistic that you mentioned earlier, I feel like the significance of that statistic could be questionable. Out of 35,000 neutrinos that they studied, only 20 of them had high levels of energy. I mean, those 20 could have easily been just simple irregularities or anomalies that were detected but weren't actually there. Also, many neutrinos can also originate from other places other than the cosmos. You were talking about how they come from supernovas and black holes and quasars. Well, neutrinos come from radioactivity and radioactive decay. They can easily come from nuclear bombs, nuclear power plants, and even the digestion of potassium. They all can lead to some radioactive activity, some radioactive decay. So there's nothing really to say that all these neutrinos, all these 35,000 neutrinos that they collected, were from outer space. They might as easily have come from some nuclear power plant.
Alright, thank you, Daniel, for sharing your opinions. Daniel, do you have any more evidence to support your claims?
Yeah, I do. Another point that's important to make is that these high-energy neutrinos, being outside the galaxy, that means that they have to travel long distances, right? They have to travel a lot. Wouldn't they hit nuclei by then? I mean, neutrinos can permeate through solid material, sure, but when it collides with the nucleus of an atom, a muon is formed. This is how scientists can detect neutrinos in the first place. How is it that long distance that they traveled, neutrinos can go far without ever contacting a nucleus before getting to Earth?
Alright, Shawn, do you have any opinions on Daniel's statement?
Well, you may provide a fair point, but I have to disagree with you because the neutrino's permeability through matter is due to the empty space within atoms. So, comparing it to a relative size, if you take a football field and put a P in the exact center, that would be the nucleus of an atom, and then the electron cloud would be the entire outside perimeter. So, as you can see, there's a lot of empty space which the neutrinos can go through.
Alright, gentlemen, do you guys have any closing statements before we close this debate?
Actually, yes. In the Antarctica experiment, where 20 out of the 35,000 neutrinos had high energy, those 20 neutrinos came from the same direction, showing that those 20 neutrinos most likely came from the same extragalactic source.
Daniel?
That is a good point to make. However, one must account for, the rotation of the Earth. Not only just the rotation of the Earth around the Sun, the rotation of the Earth around its own axis, the spinning of the Earth. I don't feel like these recordings would be very accurate. If they're all coming from the same direction, are they accounting for the Earth spinning? If they aren't, then that means that these high-level neutrinos are coming from all over the place. Meaning there's not just one source, it's probably coming from within our galaxy, and these are just different anomalies.
This concludes our debate on the possibility of neutrinos coming from other galaxies. I would like to thank our speakers Shawn, Gani, and Daniel Sanchez. I need friends.